Shubham Agnihotri for this podcast. This is a kind of a podcast where I was always waiting to do with him. He's a gamer during the night and he's just a data scientist in the morning. Like he makes decisions using data and playing games, he just makes decisions using his brain itself. So I think probably this is kind of a podcast where I was always waiting to do because today there's an intent of gaming with machine learning, AI, and other technologies today. I think there is a lot to demystify in terms of the performance, the way in which models can be deployed in the future, and a way beyond it. Trust me, he's a data scientist in Arcadis during the morning. I don't know how he finds time during the night to play games. And like, yeah, he's one of the most fascinating personalities that I've ever met. So yes, let's just demystify some more beyond the gaming, beyond the data science. Thank you, Shubham.
Thank you, Vishwas, for having me here. You spoke a lot about me. It is actually my honor to be here, and I know I was kind of slightly busy for last couple of weeks. You asked me this, and I'm really sorry for that. And even I'm really excited to do that. I really like this concept, and let's see how it goes. So yeah,
Sure.
thanks for having me here.
Yep.
Yeah.
I just want to ask this question for all the data scientists. I recently got across this question to all the people who are in the hardware and the software field. What's the actual potential of the intelligence when it is built on a computer? Because we still ponder upon the fact that neural network is not as sophisticated as brain, but we are trying to build something new on a computer. So I want to ask this question. What's the actual potential of intelligence when built on a computer?
Okay, so when you talk about potential and when you talk about intelligence, so firstly, if I want to answer about potential, I would say it's huge. Secondly, before answering to the intelligence part, I want everyone to understand what exactly is intelligence. So you can frame this in such a way that intelligence is the ability to understand, learn, and think. So basically, kind of you interpret what's around you, adapt, and then you take decisions on its own. Right now, we are not at that stage. Like for some applications, definitely we are, but for not all of the applications, or in general, we say. So the potential is huge. Now, let's say if I take an example of, let's take in India itself, we have Siachen, which is, I guess, the highest battleground ever to like you for war or something. So currently, I would state the government itself is willing to pay 5,000 crores if someone builds a robot that can, just transfer goods from down to up there. So let's say if we talk about potential now over here, if anyone comes up with that machine, which is able to understand the environment, because Siachen is a very difficult terrain even for humans to go up and down, and then act accordingly and adapt and has the ability to think. It's pretty amazing. It has got huge potential, and when it'll happen, maybe soon or maybe it'll take some time.
Yeah, that's true because we have not yet completely demystified how the brain really works. Because even scientists today are pondering upon the fact that brain is still existing, but we don't know how it really works today. So yeah, I think probably we are going to achieve such kind of potentials one day where we dream today. Yep. And like, how did this technique of ML develop over the course of time? Because computer architecture has been an influence here, but like, how has it been the true influence? Like, according to you, how has the computer architecture made that influence in the field of AI, ML, machine learning, ML, and computer vision?
Okay. uh, Hardware plays a really important role when it comes to machine learning or AI. Let's talk about the history first, when computer were actually made. At that time, people were more into let's solve this problem. Let's say they were like, if we want to build a calculator, 2 plus 2, can a machine do that? That was the real challenge over there. Then they built the computer, evolved from 1950s to what we are right now, where we have GPUs and TPUs and QPUs coming in to solve not just 2 plus 2 to like to solve millions of threads of that 2 plus 2 together. So right now the problem is much different as it was before. Right now, the problem, what we're trying to do is how fast we can do those calculations and how efficiently we can do those calculations. So there was a time in 1950s where we had stochastic gradient descent as an algorithm on paper, but we did not have any hardware to do it. And right now, again, there is time where we have quantum algorithms on paper, but we don't have the hardware to do it. We cannot test them out. So definitely these algorithms kind of give a push to the architecture as well as they say that we need more and more hardware to perform, and as soon as there are more and more advancement happening in architecture, we can scale this up to a new level because as you saw the momentum of how it was initially just solving the problem to now it is how efficiently and on how fast we can solve the problem. So architectures play a huge role, and in all the techniques they have influence machine learning because let's take one more example onto this. There was a time around 2010, 2000, 2011, 12, 13, where there were, if I talk about neural networks itself, where there was an AlexNet which said, okay, I can use two GPUs at once and do the training. Now, if you look over here, AlexNet gave the idea of it. Now every other algorithm is using that, and now they're like, now what all we can integrate onto that, because now we have the hardware support. Now what? Now we look on increasing the algorithm's potential, and once we again reach that cap, and then hardware is like let's push one further, one further, one further.
Yeah, that was true actually, because way beyond that, I think probably 2011, when there were ResNets and all these architecture, residual networks came in, like they were like more compute intensive from the, I think it was from Microsoft Asia Research, I think
Yes,
so.
yeah, ResNet
ImageNet,
was from Microsoft. Yeah,
yeah,
ImageNet is from Google. Yeah,
yeah,
yeah.
ImageNet architect. That was a challenge that they took for the ImageNet, and then they came out with all these architecture. I think that has led to the foundation of everything. Like I follow a lecturer called as Honor Mutlu, and he's also into bioinformatics. He's from Carnegie Mellon University. An amazing guy. He has
Okay.
been working on so many aspects, bioinformatics, self-driving car, this, that, technology. And once I thought to myself, there is an influence of machine learning. Yep, there is a huge influence of machine learning today. Like, I just want to ask you this one question. The biggest problem in data sets, when are we trying to solve them? Like, some of them are still canonically still left behind the hood. Like, they have not been touched, they have not been solved. Like, what are those problems? What is the biggest problem with the data science? Would When will we try to solve it? Like, when are we just going to test that? Are we just waiting for some breakthroughs, or what is it all about?
Okay, right now I'll give a slightly different perspective towards, I'll talk about two perspectives over here. One is, the problem in data science with respect to us, the people around it, and the problem of data science with respect to the technology and every other aspect of it. So once we talk about the people, uh, when we were in 1950s, yeah, I like a bit of history, so I like to relate things back. So when we were in 1950s, people were there and they were saying we cannot let computer come in and it'll take away all our jobs and all those this and that. And now we have compute, like now we are in an era where each and everyone owns a smartphone. Like few of them owns multiple smartphones. So right now the problem with data science is pretty much the same, that people are not ready to, like there are two things. One is the mindset and one is the presence of mind. uh, so what exactly is mindset? Mindset, we can think, you can take it as there are some assumptions and notions by which a person reacts to it or lives his way via it, lives his way. So a lot of people right now are not ready to adapt. We we have seen and we are continuously seeing that there have been, news articles here and there flashing that, this company just fired these many people because now the machine can do that job. This company fired these many people because, AI took their job. And there are, in some part of the world, there are revolts happening that, we should not adopt AI, or, all those things. So this is with respect to the people, that, the biggest problem with data science with respect to you is that, if you're not changing, it'll take away your job. So because we have a brain which is, amazing, I would say, what amazing thing, that it is capable of performing so amazing tasks. And you doing such a task that can be easily done by a machine is not what it should be used for. And that is what, even companies are saying, that, if you have a presence of mind, that means you are proactive in analyzing things, that okay, data science is doing this thing, so let me learn something else which is more meaningful, which is more useful, so that, I can deliver a more meaningful output to it. And that's where even you evolve and you stay on with the technology. So this is with respect to the people. Now, with respect to data science, I would say, what are the major problems? I would still say hardware is one of the biggest concerns, that still is very challenging to, to test few algorithms out, or even, let's say, if you want to train something, for one algorithm for Tesla itself, for self-driving car, it takes around 3 to 4 days itself on such high computation. They have GPUs and GPUs loaded. They are billion-dollar companies, and they have stacks of everything involved, like connected in parallel one after the other, and still it takes 3 to 4 days to do that. Now, if you talk about you and me, it would, I don't know how many times, how much hours, or how many days it'll take for doing that. So if hardware evolves faster and evolves exponential, these things will slightly reduce for us. And even overall, as a with a research perspective, it will also enable us to test more and more application, more and more algorithms, and a lot.
Yeah, do you remember like 6 months prior or somewhere like last year, Nvidia bought ARM for whopping $40 billion. Like that's a huge disruption. I'm not joking
Yeah.
because TensorFlow is with ARM. There are other companies which are just getting in. So I feel probably one day there's a huge influence of edge in a lot of decisions that we make tomorrow. Yeah, that's for true.
Definitely.
That's true. That's true. Because even you told about GPUs, I think probably edge TPUs are already available, the Coral board and all
Yes.
these. And yeah, it's the best. Your favorite question. What's the influence of gaming
Uh,
in the world of
yes.
computation today?
Yeah, before answering to that question, I'll just add on to the thing which you just said right now about the edge. That yes, people, everything, like, nowadays everything is on the go thing. That you want everything on your phone. Like, if you have it something handy, it's pretty amazing. So there have been different architectures as well, that they're trying to test on phone, whether you can just run it on phone and get the output immediately. So even testing that, going on to real time is again, slight challenge with a data science, because uh, there are some applications where, how do I frame it? Hmm. Yes. Now, let's say if you're talking about medical or healthcare facilities, there are, over here, I would consider it as various categories which are very much sensitive, because any wrong decision can cause a lot of chaos and can even lead to deaths. So we need to be 100% sure in that categories, and because it involves someone's life. So even solving those things are one of the biggest challenges, because we need to be 100% sure, that there is no chance of error. Same with self-driving cars. The current scenario with self-driving cars are that a lot of them, I guess 3 4 years back itself, they had already beat human accuracy. That means, let's say, if 80% of the time a human drives cars perfectly, and 20% of time he just bumps and gets into an accident, The self-driving cars beat them a lot time before, but they are still not much onto the roads. Like we see some of them on the roads, but no, not 100% of them, and they are like, every other company is just selling it out. This is because we want to be 100% sure that if it involves somebody's life, then better be 100% sure. I would say 200% sure. So that is again a thing with data science. And the thing is, everything revolves around data. So if you don't have enough data, how can you be 100% sure? Because you need to be covering each and every aspect of it.
That's true.
So,
That's true. Like, yeah, let's just go on to your favorite question. How is the influence of gaming in the world of computation today?
influence of gaming. Me being a gamer myself, I know gaming has changed a lot in computation. When I used to play games before, I had that Pentium CPU,
I even
Intel
had
Pentium.
worse Celeron processor, 512 MBs of RAM, playing GTA Vice City. That was my first encounter for the gaming. Now
We played
it's,
GTA Vice City in that. Nice.
yeah, it was it need not have that amount of logical rendering. Like, it need not have that amount of compute. Like, even we have also drawn something on the shirt. Like, you could easily edit it.
Yeah,
That was amazing. Those were the amazing days of gaming, initial days of gaming.
yeah. I wouldn't say those were the amazing days. I would say those were the initial days of gaming, where because gaming itself wasn't evolved much. There were 2D games coming in, like we had the Adventurous Dave or Mario or Contra and all those games coming in. So it did not require much of a graphic processing. What I mean by graphic is like you have multiple things going in, and uh, multiple visual effects coming out or something like that. Now, when it came to 3D, the games which kind of created an impact were definitely the Rockstar games. They were We have the Rockstar games, the Ubisoft, Rockstar games, which is the GTA and all, Ubisoft, and we have different companies which came in, and they were like, we have this game, it requires this hardware or something like that. As it, I would say it was more of a demand and supply problem, where we had a demand of good hardwares that should be readily available to the people. Because if you're making games for the people and it is expensive, then who is going to buy it? And if people are not going to buy it, if they don't have the hardware for it, then even the hardware company fails out because they're not able to sell it. They have just limited number of people who are just researchers or the research organizations. So they were like, okay, we advance in the hardware, and as soon as the advancement happens, you already open to a very huge market where people have hardware, so they can play complex games. And then right now, even there's a game called Call of Duty, I guess, Warzone. That is a 250 GB game. If an update comes onto that game, it again costs around 100 GB. Right now, we are able to play that game, which wasn't even possible back then. And I would say with a decent GPU, everyone can play that game. That is what we are talking about. There was a demand, and then the supply came in. So there was again a demand of slightly gaming. People wanted to play games, and even I would say the career in gaming kind of evolved soon after that. That once hardware became cheap, things become easy and accessible.
Yeah, that's true. That's true. Everything revolves on the price of the silicon. No way
Yeah.
that you can really just afford to make it much more cheaper, because fabricating it is a cumbersome process. That's true. That's true. But like, how much is the understanding of the machines in playing games? Like, today, machines are intending to play games like reinforcement learning and things like that. Can we alter the intelligence tomorrow? Like, can we just build a real brain on a GPU or a CPU? That's my question. Like, because how much are we just understanding the fact that it's a synthesized intelligence and it can't be as accurate as a human being? Sometimes what we are, like I'm saying, like probably we might get fatigue over the course of time, but computer does not get fatigue. But I'm just asking you in that sense, like how much is your understanding about the machine playing games, and can we alter the intelligence? Can we just have that synthesized intelligence, which is as realistic as what we see today through brain?
Sure, it is a good question. So answering onto that, what do I feel about gaming? What do I feel about AI in gaming, or machine learning in gaming? I would say the reason why we do it in gaming is because it is a controlled environment. You have a set of rules saying that you cannot cross that line, or something like this would never happen in this world, so you don't need to take care of it. So you have a predefined set of rules. Now let's say, let's take a real world example itself. I would compare that in a gaming world and then in a real world. So let's take a self-driving car. So in self-driving car, how do we test it on a gaming environment? What we do is we create a map, we create some buildings that we mark it as a car shouldn't go there. We kind of create some people saying that if you saw someone crossing, just don't just stop the car and don't or run over them. And then we have these set of rules that don't do this, don't do that, and the environment is fixed. That means the building will stay over here, the road will be straight always, there will be proper roads, there'll be proper markings and everything. So the game, I would say, is a very ideal environment for machine learning to work in, because it's fixed. And when we come on to real world, there can be someone driving wrong side. There cannot be proper roads. If you talk about India, there cannot be proper roads, you have animals on the road. Then recently, there not recently, few years back, there was a news that a self-driving car just bumped into another car because it couldn't recognize it as a car, because it was, I guess, in a very different angle to what it like to the camera, and because of that, it wasn't able to recognize it. So that is where that the challenge of AI, or the challenge of reinforcement learning comes in, because how can you make it work onto real time? You have someone may jump onto the road, which may not happen in the ideal scenario. Let's talk about the worst case scenario, saying that because of some you're driving through it, and let's say you're driving on a mountain terrain, and there is a landslide in front of it. No one have ever created something like that in a simulation, but that happens. And how is your car about to react that? So uh, computers playing games is easy, and it's, I would say, it's a 101 thing to run it on the real world. So yep. And the second question was, can we have an alter intelligence tomorrow? Definitely. I still feel that we can have a general intelligence, and who can perform everything. Let's say if we talk about human can drive a car, human can call a person at the same time, listen to the music at the same time, eat something while driving, can do n number of tasks at the same time. And computers cannot, but they can. They have the potential, and we are on the run to do it. I hope I answered the question, because
Yeah,
I'm
you
not sure.
answered that question. You answered that question. Yeah, bro, you are now there as not that a kind of a fresh data scientist. You have been in industry for almost like 1.5, 2 years right now. So you have seen different industries adopting this technology. Right now, this is the hot cake. Like everybody needs it. Whether it's AWS, Azure, GCP, everybody runs the payload of the machine learning models, whether it can be in any file form like H5, Pickle, or anything. Right? It's
Anything.
still a machine learning model. It has some weights and things like that. But like, what is the effect of machine learning and deep learning in all the industries today? Because I saw machine learning making huge and appropriate decisions in the field of medicine, in the field of automobiles, and now even in making shares. Like there is an intent of swarm intelligence in the share right now. Share markets, there are companies which are coming out with these kind of models and things like that. What do you feel about the price point of the intelligence that we are going to see tomorrow? I am talking in terms of like literally deploying it for somebody who is just wanting to just understand how the machine learning works, and he wants to play with the machine and his money, something like that. And how is it effective in all the industries today, according to you?
Okay. I'll talk again. I'll talk both the perspective right now over here. You said what is the impact, or what is how every market is getting affected out of this. So I would say, and then you discuss about stocks or shares. So right now, machine learning is one such thing that there's a real incident about a company that just changed its name and added crypto to it. The next day, their stock booms up. Why is that so? Because people believe in this. People believe in, and they had nothing to do with crypto. Nothing. They just kept it because it was rhyming with their product. So people believe in these technologies. They see this as a future and something ruling the world. As you pointed out that we have various different companies coming onto whether it's share market, medical, then I would say weaponry, and you have even cyber intelligence which is coming in, where you can you have uh, you monitor different transactions and you check. Then again, you also try to prevent different attacks coming onto your system. A lot is happening in the deep learning industry, and again there is people over here are trying to take a very huge advantage out of it. There have been many various cases. This is kind of the bad side which I'm talking about, that people take an advantage of it. Now let's say I talk about the crypto name. Then second is we have a lot of companies claiming that we use AI, but what do you see in the back end is not AI. There's something, just an if else statement which is kind of doing the job. But then there have been even companies, those are doing phenomenal in AI. Like you have the deep minds, which are like if you talk about the reinforcement learning research they have done is pretty amazing. They're trying to replicate uh, in the gaming environment. They're trying to see how things can work and then replicating it in the real environment. Then we have companies like Tesla, which are trying to solve the self-driving problem. We have again company like, I guess its name is Go Simple. Am I allowed to take company name, by the way? You can beep
Yeah,
it
you
out if
can,
you
you
if
can, you can, you
yeah.
can.
Hmm.
I'll put
So
the appropriate overlays for it. Don't.
yeah. So you can they, I guess it's Go Simple. They are at, I guess, the highest level of self-driving car, where I guess they are very close to level 5. They are even ahead of Tesla, but very few people know them. They are startup. We have n number of startups coming on. Like we have this company called as first share market. I guess it's Red Robinhood. Robinhood. What does Robinhood does is they kind of even in India we have if you talk about, let's say, any bank, ICICI Bank, what they do is they have different algorithms running on the back end. What they suggest is based on this history, I think the stock will go up. It's just technical. It doesn't really matter what the news is in the market, what everything is there in the market. They just predict how it's going up, and it is solving everyone's problem. Obviously they charge for it, but it it eases things out. So if you talk about AI as a whole, how it's going to affect the market, AI is to ease your life, whether it's with respect to healthcare, because you feed let's say if there was a disease in 1950s, and again there's a new strain coming onto it, the doctor currently who is posted may not know that disease very well as a person living in 1950 may know. But an AI knows both the things because it has the data of it. So it is for easing things out for people, and it is going to impact each and every market. Right now, the least affected market is agriculture and construction. Construction is one which I am in right now. So this is, I would say, is a new genre where AI has to impact a lot. Let's say if I give an example of construction, we have different petrol pumps, right? These different petrol, and we have underground water, and we have different sewages, and everything is underground. These tanks cannot hold much petrol, like cannot hold petrol for a very long time. They leak, and when they leak, they contaminate everything. So you need AI to predict all those things, that oh, when are they going to leak? Okay, this is the amount of time, so I should go. The company should go and do a check or just change things here and there and prevent things from happening. So again, kind of again AI is used for controlling the damage that can happen. So you just predict the future, you make life easy out of it, and live happily is what AI is going to impact.
Yeah, that's true. That's true. Because we are just trying to make ourselves easier, make our lives easier. It's not that kind of a complex deal today because everybody needs something or the other to work on. So there are problem statements lying. Just go on, just get your niche, just understand that, just start solving it. Simple as that. So yeah, like as a do you I think you remember the first day that we talked before joining a TFUG Bengaluru chapter. Like, yeah, I know we talked about quantum, we talked about the cloud computing platforms and things like that. And like
Yes.
you actually emphasized on like I hope another 5 to 10 years quantum computer might advance in terms of research and things like that. Like I want to ask you this one question particularly, like what's the intent of quantum computing in the world that is still nagging behind GPUs and we don't really have an quantum hardware built, but but there are potentials of quantum computing in different fields like medicine and things like that. So how far over the course of time is quantum computer going to play games, just make decisions in medicine, just make decisions in something new, like even Bitcoin mining has been made easier through quantum computing? It seems there are papers, there are articles on it. So what's the intent of quantum computer tomorrow? Over the course of time, how are they going to be more influential than our colloquial computing platforms?
Okay. So how far are we? We are in a short answer, I would say we are very far. And then in an elaborated answer, what I'll say is the reason why quantum computer is not here is because the quantum hardware is not here. And why the quantum hardware is not here is because quantum hardware is very difficult to maintain. If I go into specifics and answer this question, I would say that to be in a quantum state, we have to be, I guess, 0.00001 Kelvin close, which is very close to 0 Kelvin, which is the absolute zero. That means we cannot have a temperature close to that, like, below that.
Yeah.
Mm. So, yes, so, maintaining that quantum state is really difficult. Right now, I would say the quantum computers which we have, one is like, we have from Google, we have from IBM, and even Microsoft is developing onto it. These use different architectures. I don't want to go into the specifics of it, but then each of these architectures can maximum run for about 1 millisecond, and after that it loses its quantum state. How does it lose its quantum state? It's either because of the noise, a slight noise from the resistor beside it, or slight heating of the resistor because of that operation, and we lose the quantum state. So, what we do is we give an input, it goes to the quantum state, solves a problem in the quantum world, and then comes out because the quantum computer cannot hold itself. So this is a very big problem, which everyone is facing right now, and that is why a lot of research is going on to the hardware. Because if you talk about playing a game requires a lot of I would say data transfer happening here and there. Let's say if I press, let's say if you want to run an AI, let's say for Atari games itself, uh, we want to play Pong. I move this, the ball is moving in this way. That data has to go to the computer, and then the computer has to say, okay, this is what you should do, and it should come out. Now every one millisecond, your computer just booms up and says, I cannot stay in that, and then it again has to go into that quantum state, then solve the problem, come out, and then again go into quantum state and solve the problem, come out. It's kind of tedious, and it makes things slow. And what happens is, again, you need to sell the whole bunch of data again, because as soon as it loses the quantum state, everything is lost. So what happens is, let's say if an operation is really big, it can happen that in the mid of an operation it loses the quantum state and things go haywire. So are we close? I don't think so. uh, It be used for solving real world problems? Definitely. Quantum computers, I think, are the next big thing that will be happening in the future because they they solve things way much faster than what normal computers do.
Yeah, that's true. That's true. Because we are just making sure that they go to the superconducting state, and we are just using the physics to understand what's the mechanism of all the things that we are just trying to solve. Yep. I think we might not be very close to it, but like theories say that probably in the next century, probably that might happen. Yeah,
Yeah.
sure. But like quantum machine learning, what's your view on that? Like, I really wanted to ask you this question because you fiddle around with the algorithms, you fiddle around with how my data set can make that storytelling. But like quantum machine learning is something which is way beyond the reach of a human potential, because people saw that there is a potential in it, and they're not yet completely thought given a second thought of not going away from it also, even though there are algorithms which are not that easily available and things like that. What's your view on quantum machine learning these days that we are trying to develop?
Yep. What I feel is quantum machine learning is the 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 way to the AI, the next advanced thing. I think it is going to solve what we call as the artificial general intelligence. The reason I think that is because how quantum works. Quantum machines are good in solving matrix problems. So, if we have anything in a matrix format, whether it's any operation on the matrix format, quantums can do easily, like in just a click. They um, there's always a debate of whether quantum will take over the classical computer. No, they won't. But if you talk about computation, definitely they will. And in AI, what takes the most amount of time is the computation. That means you have a lot of data, you feed that data, and then you have a lot of learning happening, and there's a huge process in between. So once we have quantum machines involved in it, to train, that's what I was saying, that let's say a self-driving car takes around 2 days to train on a normal GPU, or I would say a bunch of GPUs. I would say it will take less than half of a time when it comes to quantum, because they are going to do things exponentially. Let's say, because over here, if there are n bits in quantum, it goes to 2 raised to n. This is the power of exponential what we are talking about. I guess there's a theory. I wouldn't say a theory. There's a fact that if we have a quantum bit of around n equals to 100, that means we can create. I may be wrong with the number. You can just correct it in the video when you edit it. So it says that if we have, let's say, n equals to 100, we can simulate the whole universe, the whole current universe which we are into right now. This is the power we are talking about. That a machine that can simulate the whole entire universe. So quantum machine learning, when it comes to quantum machine learning, things will be way more faster. Right now, any algorithm takes a lot of time. Machine learning, quantum will be like, give it to me, I'll do it in fraction of seconds. And then we have the quantum data also coming in. Quantum data is like, oh, you're taking 500 GB of this much data, give it to me. What I'll do is I'll again, make it like, in the same 500 GB, I can have around 2 raised to 500 times of data in it. So currently, how quantum data works is, because if you're talking about quantum machine learning, we need quantum data into it. We cannot feed in classical data. We need data in quantum state. So if there are, let's say, n bits of data, so that n bit in normal thing represents, let's say, 10000. That is one data point. Whereas when it comes to quantum, it is 2 raised to n. That is the power which I'm talking about. That we have a lot of data in that small package, and we have a lot of computing in those limited amount of bits. And once you give this to a machine, and that can take a lot of data and process things faster, you will have outputs faster. So whatever theories we have can be tested faster, and a lot of theories can be proven correctly, can be proven, okay, this was just a theory and cannot be, proven in real world. So a lot of advancement can be made really fast. So
That's
yes, quantum machine learning, I think, would be amazing when it becomes real.
yeah, reality of making it much more realistic. Like we are just fascinated by the potential of what algorithms have taught to us. I think probably if we completely demystify and build it, I think probably it's going to be much more bigger than what we are thinking about it also. Yeah, like talking about quantum machine learning, of course it's quite far from the reach for all the data scientists who might be working on. Of course it's reality to some folks but not reality to all of us. So I would love to ask you this question on AGI, like artificial general intelligence. It's the new buzzword that everybody wants right now. Like they want Alexa to be their mom, dad, everybody, girlfriend, even if they're single. There are people where I think you should have seen this movie called as Her, and a person falls in love with an AI voice, and that's what it is all about today. So I just want to ask you, like, how far are we in getting AGI as the new reality? Like, how close are we also in order to get an AGI, a working model of an AGI?
I would still say the same answer for what I said for quantum. It's like we are very far, honestly, because AGI is something that a machine can perform everything. Let's say if we talk about a set of things a human can do, uh, like how I gave an example of a person driving a car, talking on the phone, eating something, listening to the music at the same time, and still driving the car correctly. And there are a lot of aspects involved to it. Let's break it down one by one. Okay, a person sees it. That's where vision comes in. A person is listening. There are a lot of hearing sensors which are coming in, and the person is responding back because who's on the call. That is one more sense coming in, and giving the answer. And then we have someone, let's say he's eating as well, so again, one hand is on the steering wheel, another hand is eating, and then you have his, again, the person is speaking and then eating and then speaking. There's a lot of rhythm onto that. So once we come onto I think it's really far. The algorithm, I think, which was really close, who could perform multiple different tasks together like this, was AlphaGo. Sorry, AlphaZero. AlphaZero is advanced version of AlphaGo. So AlphaZero, what it does is, it plays chess, it plays Go, it plays one few more other games which are board games. So that is where intelligence comes, like general intelligence comes in. Now let's say if you talk about board games, then AlphaGo will be like, I'm the intelligent, I can play everything. But when it comes to a normal human being or reality, when you come out of games, intelligence has to be something that can do everything. You can understand a language, you can reply back, you can understand what's around you, then you can perform tasks, you can act based on the things happening around you. It takes a lot of research onto it to doing it, and I don't think so anyone is anywhere close to it. What AI currently does is, you're right, there is a very, I would say in layman terms, in every college they teach it as, there's a weak AI and there's a strong AI. What they determine by strong AI is the AI which can do everything, basically the artificial general intelligence. And rest everything falls under the weak AI category. That is, you give it to a specific task, they can do that specific task amazingly. But when it comes to another task, which might be very similar to the previous task they learned, they may fail. Whereas human may not. Human be like, okay, I can see there is a correlation onto this. Let me try onto this, and sooner or later they will learn. So for AI, it is slightly a bit challenging, and I think it is again going to take a lot of time because, firstly, I haven't seen any algorithm that says that, we implement this and this is going to learn everything. No, I don't think so. And again, the hardware to do such thing is going to be, has to be very big, because just a self-driving car itself takes a lot of time. So just think about, creating a whole human being who can do not just driving and can do n number of tasks. So it's gonna we need quantum for that is what I feel. And
Yeah,
until unless quantum comes in,
you
or
are true.
something.
You can
Thank
say, you
you.
can say, you can say.
Yeah, and or something exponential growth in GPUs that we have reached to a very 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 huge height, that some of the billion-dollar companies or trillion-dollar companies have the the money to create that stack and then train it. Can be, but quantum would be much easier, but a lot more expensive than that.
Yeah, that's true. That's true. Because, there are ways in which we have just built an intelligence. Like a neuron was actually something which was built using some hardware and things like that. You can even learn how to build a neuron today with just some software like TensorFlow and things like that. But I think probably over the course of time, I even have heard in some TED talks like people say if you would have said what computers can do today, I would have laughed at you like 10 years before. If you would have said the same thing to me, what a computer can do today, I'd have laughed at you. All these things, like probably, I think probably when I'm old, when you are old, when we both experience the same discussion, like, we had done a podcast on that day and we are told AGI might not be, probably AGI could be a reality during that time and we might be discussing, okay, they have used this algorithm, that algorithm. It's so funny that technology is like way beyond the reach of any person, like it's just evolving. So you are a data scientist, so I can't just leave you out of the podcast without asking this question: what's the nature of the data set tomorrow?
What is the nature of the data set? Uh, Data actually plays a very important role in machine learning or artificial intelligence or deep learning, whatever you want to state it. The amount and the quality of data, there are two aspects of the data. One is the amount and one is the quality. If you have a good amount in the sense your data covers almost every aspect of it, whatever the problem you're trying to solve is a good amount. And how good it covers is the quality. So what I feel in the future is the future is going to be so if I relate to my previous answers what I gave, I would say what I feel is quantum is going to the future, is going to be the future for machine learning. So will quantum data be? Because even I wrote an article on Medium onto this, that how quantum is going to evolve, and I just slightly mentioned on how quantum data works. So let me just pull that up. I can state it out what it was. So basically, what happens in quantum data is you just take um, n bit, and that n bit can transform into 2 raised to n bit. Now let's say if I take a power of 4, a power of 4 in the sense we have 4 bits which are going in. This is, I guess, Intel 8085, some long back processor which could take 4 bits of input. If we go into currently on quantum, that can process around 2 raised to 4, which is 16. So this thing goes on exponential and exponential. That means on the 4 bit you can represent um, 16 data points, 16 different data points on just that 4 bit. And if let's say, because they are in the entangled states, so that means it's either 0 or 1, it's either 0 or 1, it's either 0 or 1, it's either 0 or 1. So when it was a classical computing thing, it was either 1 or 0. It has to be one thing fixed. So when you look down in the end, it is one fixed value, which is, I guess, 1100 or whatever value it is. Right now, when it comes to quantum data, it is either of these. So it can be in any of the states. So it can represent any of those data values, data points at the same time. So that is where I feel even the data, the things which are going in the future are going to be, because uh, we know that all these algorithms are data hungry. So if how can we feed that quantity into it without giving a burden onto our storage devices? Use quantum data. It sounds very simple right now. Quantum data is very difficult to make it or even to store it. there's something called as quantum drives, but again, not into a reality. But maybe what I feel about the data of tomorrow, definitely quantum data.
Thank you so much, Shubham, bro, for this amazing podcast. Trust me, I had the best day of my entire like career of a student or something. Back to back to back. Like every week, I don't know why I always find guests like you, and I'm so happy that today you brought a new insight to me for the data science. I think, trust me, you're doing an amazing job in terms of educating yourself, and also you are doing a great job even in terms of gaming. Trust me, I'm very happy that I'm a part of the team that you are also indulged with. Yeah, thank you so much for this amazing podcast, Shubham, bro.
Thank you, Vishwas, for letting me join this podcast. We had planned this for a very long time and we couldn't do it. And even I was so excited for it once you told me, okay, we are going to do this, and I was like, let's do it, because even I was excited for this. I saw your previous podcast and I was like, I also want to be here. And I loved your questions, whatever you asked. They were those were pretty amazing. Something which even brought me into thinking, okay, we can have this perspective as well. When once you asked this question, I was like, oh, there are this perspective on this side, there's this perspective on this side, and a lot of them. So I love your questions. Thank you for bringing me here. It was a
Yeah,
great
it's my
pleasure.
pleasure. It's my pleasure.